Have you ever played Flow Free? It's a lot like routing circuit boards, actually, especially if you do Flow Free with bridges, where the bridge might be a resistor coming up underneath. And you've got to join a whole bunch of things together, and you can't cross the lines except where you can run it underneath a bridge. And so if you want some practice, pick a harder challenge than that and take a look at what you can do just getting your mind in gear for routing circuit boards by playing flow-free or flow-free with bridges. In today's circuit, we're going to be making a circuit called the Monobox. And you can find this circuit online by just Googling Make for Make Magazine and Monobox, and that will take you to the Monobox powered speaker. And basically it is a very nice little low powered amplifier. They spend a lot of time talking about how you can take any old box and put any old speaker into it. But we're going to take this and we're going to use their schematic to create our own printed circuit board. This is actually a project that we do with second year students in technology teacher education at British Columbia Institute of Technology, because it's a great project to do with high school students when they're learning about electronics. The LM386 chip is a relatively inexpensive amplifier, and you can plug your phone into it and use a relatively inexpensive speaker, run it off a 9-volt battery, and it lasts for a long time. Now, they talk a lot about making the box, and quite frankly, that's not really the electronics part of the project. One of the nice things about it as a technology project, though, is that it is an integrated project that involves some recycling. We're going to be taking a look at the schematic, and the schematic is shown right at the bottom in a section where it talks about how your amplifier works. And so there's an explanation on here of the LM386 chip and how it works, and a schematic that we can use to create our circuit. Now, I spend a lot of time breadboarding this with students, and it's a great breadboarding exercise because you can get this working on a breadboard as well. But today we're going to take a look at how to make the printed circuit board version of it. So just a quick summary of what we're going to be doing here. Your MP3 player, yes, well, that might be your phone now. Some of these details have been around for a little while, is going to have a ground line right here. Now, this is just a different symbol for ground, and you can see that everything right along in here is tied to ground. And there is a ground line as well right up there. And here we've got our 9-volt to 12-volt line coming in right here. So this is providing power to our circuit somewhere between 9 and 12 volts. So a 9-volt battery works really nice. And we've got a power pin and a ground pin on this chip. Now this is a little 8-pin integrated circuit. We can get it in a dual inline package or a dip package, which is a through-hole package, so you can drill your holes and solder it onto your circuit board. We don't actually solder the chip directly to the board, we solder a socket into the board, and then we press the chip into the socket. So if you burn out the chip due to some kind of short circuit or that, it's easy to replace a relatively inexpensive chip. As our signal comes in right here, it comes into one of the input pins on the amplifier. And so our signal is going to come in at fairly low level from your phone because your phone is designed to drive headphones. So this is actually going to be a headphone jack right here. And in fact, we're just going to solder the connections for headphone jack. That's going to be a line that comes out over to here and plugs into your phone over here somewhere, or into your laptop, or into whatever audio source you like. Now, when you're doing this with students, I do recommend that the first couple times you try it with a relatively inexpensive audio source, because there have been known to be times when somebody accidentally solders this line up to the 9-volt line, and they end up running 9 volts straight back into the audio jack of their phone, and that's not good. So do find a relatively inexpensive test source for your audio when the first time you go to hook this up. So anyways, we're going to get an audio signal coming in from our phone. Now you'll notice we're only getting one audio signal right here. The reason it's called a monobox is because it is a mono amplifier as opposed to a stereo amplifier. A stereo amplifier would have 3 lines coming in from your phone. It would have ground, it would have your left channel, and it would have your right channel. So typically we'll use the left channel coming in right here. And if you want to make it into a stereo amplifier and have two output speakers, well, then you can duplicate the circuit and run a third pin in right here. We're going to use a stereo input jack anyway, so that you're all prepped and ready to do that if you want to do it. Now, what we've got right in here is a little 100 ohm resistor, and that provides a little bit of a load for that line so that it thinks it's actually hooked up to headphones. It's not, but you know, when it's doing its sensing, it's like, oh, there's something for my electricity to do, because this chip has what we call a very high impedance input. And that high impedance input means that basically impedance is the AC version of resistance. And what it means is that no current to speak of flows in or out of that pin right there. So we give it somewhere to go right down here. And this is a comparative amplifier, so you can actually, or a differential amplifier, I should say, so it will amplify the difference between these two signals. Well, we just put this pin down to ground right here, so that whatever signal comes in here is going to get amplified. Somewhere in here it tells you how many times we're amplifying it, but we've got I think like a 20-fold gain in the signal strength coming out of there. Okay, now as that signal comes through here, you can kind of see that our symbol for the amplifier chip has our inputs on this side, and you can probably see the arrow pointing towards the output on this side coming out to the speaker. So we've got our speaker over here, and this is what's going to be making all the sound for us. So the signal is going to come in here. It's going to gain energy from the battery right here and be amplified and come kicking right out over to here. Now, because the speaker is just really a big coil right in here, and we're going to have typically about 2.5 volts on our output pin. If we didn't have this capacitor here to block the flow of DC current, this, even when there was no sound coming out, the chip would just keep sending current right through here and down to ground. We'd drain our battery, we'd overheat our chip, and it just wouldn't be good. So what this capacitor does right here is when you start flowing that electricity there, it charges up. And so you might hear a small click when you turn on the circuit. That's the capacitor charging up and squeezing a bit of electricity through that speaker. And then as we get a waveform coming out here that charges and discharges this capacitor, the changes in the waveform are going to create a change in the voltage over on this side that pulls electricity back and forth through the speaker, creating a changing magnetic field that causes the diaphragm in the speaker to vibrate back and forth, creating the audio that comes out to your ears. Now there's some magic circuitry right in here that is all based on feedback loops. And we call this one right here is a feedback filter. And what that does is that lets some of the high frequency sounds coming this way pass right through here, and they come back in here and they get sensed by the chip, and it's kind of like it can hear the high frequency sounds, so it doesn't amplify them quite as much. Now, why would you want it to not amplify the high frequency sounds quite as much? Well, what that means is it amplifies, another way of saying that is it amplifies the bass a little bit more. So this capacitor and this resistor are actually forming a bass boost circuit. And right here, this is a low pass filter, so that, sorry, a high pass filter, so our high frequencies go out this way, and high frequencies get absorbed right here. It's a low pass frequency. So any high pitched whining sound gets absorbed. And you'll find the description for that right down here in another term. So what we're going to do, we've already used Fusion 360 to create circuit boards. We know that we've got a speaker component. We know that we've got an electrolytic capacitor component. We made a we made a non-polarized capacitor component the other day. We've got resistors in there. So today what we're going to be looking at is how to make this chip. We're going to make our own integrated circuit. Now, the LM386 is common enough that you could go online and find that in a lot of libraries probably, but eventually, you know, it's quicker sometimes to just go ahead and make your own chip. And so we're going to make our own LM386 so we can see how it's done. I'm just going to take this and drag it off to my other screen right here so I can go back to playing flow free. No, there we go. I'm going to come over to Fusion 360, And here we go. I'm going to come to my project window where I'm creating all of my electronics projects and where I've got the library that I made last lesson, because that's going to have my non-polarized capacitor in it. If you don't have the non-polarized capacitor from last day, you can fake it with a polarized capacitor. But in the libraries I've seen so far, I've been not overly impressed with their selection of capacitors, so we came and we made our own. If you were following along on last week's lesson, I have gone back and I've fixed up some of the messiness on the capacitor that I made last day. Kind of brought it down to size and edited it up a little bit. So if you've got a similarly strange looking capacitor, feel free to go back and tidy it up a little bit. The last one we made was a little bit too big. Okay, so let's come in here, and as we do with all of our electronics design, we need to come to our new project and tell it we're starting a new electronics design. And this window pops right up here, and I am going to save this, and I'm just going to call this the Monobox. And I'm saving it in a project folder. I call it Winky Blink because that's just what I call a lot of these little electronics projects. And now we're going to create a new schematic diagram. And poof, the schematic window pops up right here. And again, let's save that before we get going too far. And I'll also call that the Monobox. Okay, very exciting stuff. Well, the core of this project is going to be that chip, and the challenge in today's lesson is going to be designing the LM386 chip. So let's come into our library and tell it we want to add a part. Our part doesn't exist yet, but we're going to make it exist. Okay, so here we go, and I called the library that I want to edit Jason's Awesome Library. Yeah, it's not so awesome. And you can see here that I have been practicing. I've made an LM386 already. What we're going to want to have when we're all done is something that looks like this, where each of our pins is mapped out to each of the pins on this integrated circuit, where the integrated circuit is the correct size, and where the pads are big enough that we can solder things to, and we've got one that identifies this as pin 1. Just a reminder that on integrated circuits, the pin numbering goes 1, 2, 3, 4, 5, 6, 7, 8. So it starts at pin 1 and loops around in a counterclockwise direction. Okay, so what we're going to do to create a new part, I'm going to recreate this LM386, is let's open the library manager. And in the library manager in here, it's going to come through and it's going to take a look at all of your libraries. Right now, there's none in our design, but we do have many in use that mean that they're in our system. And here we go. Just scroll down until you find your library that you want to edit. And there we go. I should have named it something like 000 or Awesome Jason's Library so it shows up at the start of my list. Okay, so I highlight that and I tell it I am going to edit that library. And there we go. I can click OK on that because I am done. Cancel that. Okay, so here we go. I've got my library open right here. The window pops up and I can see all of my library management tools in here. And I am going to create a new symbol, and it's going to ask me for a symbol name. And I'm going to call this LM386, and that's what you should call it, but I've already got one called that, and I'll call it LM386 Demo. You can get away with just calling it LM386. I'm just giving it a new name so it doesn't get confused on here. And we've got some graph paper pop up here that's going to let us draw the things that we want to put onto here. Now we know that the chip that we're making has 8 pins on it. So we want to come up here to our pin tab and we want to bring in 8 pins. So just go ahead and click on that. And before we bring them in, we know that most of them are going to be coming in mostly vertical. So let's tell it we want them to come in vertical. And the length, we can actually keep that fairly short. We don't need big long leads for each of these. And we've got some choices on where it can display the pad name. We can turn those pad names off if it's displaying them in the wrong place for us. Let's ask it to, well, we can play around with that later on, but let's say display pad name for now. Okay, the direction really doesn't matter for what we're doing, neither does the swap level. That's for some more complex stuff that you can get into later on. And so let's go ahead and bring in 8. Where did that go? Oh, I keep forgetting. If I click OK, it thinks I'm done. So let's set that back up again. And the function was okay, the length was short. There we go. And now they just come in and they're like fairly small. We've got them vertical, and I'll put 1, 2, 3, 4, 5, 6, 7, 8. I'm going to click OK right there. And so now what's kind of nice is that I put them all in sequence. So now if you refer back to your schematic, you can see the schematic for the chip has the 8 pins on it. And what we're going to do is we're actually going to put them where we want them to go. And we're going to start with pin number 1 first. You've got to be a little bit careful about this. We will check it out before we start making the circuit. So anytime you make a new part, you've got to double check to make sure that you actually get it right. But let's start with pin number 1 right here. And let's just click on that and draw a box around it if you have to. And then you can pick it up and you can move it. And we're going to put it, just going to put it about right here. Eventually, we're going to move it all down about the origin. Now, pin 2, okay, pin 2, if you look at the schematic, is actually going to be at the end. So I'm going to rotate pin 2 a couple of times and tell it that that's okay. And then I'm going to move pin 2 right up to about here somewhere. Those aren't the final positions just yet, but let's take pin 3. Pin 3 kind of gets the same treatment. Rotate, rotate, rotate. Okay, stop rotating. And move pin 3 up in here somewhere. So pin 2 was right there, pin 3 was right there. And if you're keeping a look at your schematic, you're saying, yep, that all makes sense to me. Pin 4 is going to be pointing upwards, and it's going to be located, let's come over 1, 2 steps over and 1 step down from right there. So this will be pin 5 coming in right here. Now pin 5 is going to be our output. So it's actually going to need a bit of rotation. There we go, right like that. Click OK. And pin 5 can come up right here. We'll come 1, 2 over, 1 up, 1, 2 over, 1 up, because we still need room for 1 more pin to come in right there. And so that's 1, 2, 3, 4, 5. You can see right up here that that says that's pin 5. That's its name right in there. And if we want, we can turn that on and we can make that visible. The catch is Eagle doesn't let us change the location of these names. It's a really rather awkward thing that some other programs like Design Spark do more nicely. Okay, pin 6, we're going to come in right here, and this one's going to be upside down, so let's rotate it around, and there we go. Pin 6 is going to come right up here, and pin 6 is going to be opposite of pin 4. So we'll put that up somewhere about right here. We might have to move that into position a little bit later on. And this will be pin 7 right here. You can double check and make sure that we've picked up pin 7 when we click on that. And rotate that around. It always yells at me if I don't click on just the right spot. It's like it didn't know what I was trying to do here. And pin 7 is going to come in just to the right of pin 6. And then pin 8 right here. Again, make sure you've got pin 8. And that's just going to come right up in here. And we'll come 2 over and 1 up from right there. So we've got these nicely set up right in here so that we can start drawing a triangle for them to all mount onto. And to draw our triangle, we're going to place a line right here. And what you'll want to do is you'll want to tell it that you want to draw nice straight lines at an angle. And then you're going to start drawing right down here. And you can see that because we cleverly made that at a slope of 2 to 1, our triangle comes out at a nice slope of 2 to 1. Now, it can be a little bit frustrating. Maybe you wanted it to end on that slope right there and it's snapping too tightly. If you hit the Alt key, zoom in a little bit when you do, and if you hit the Alt key, you can change your snap factor on there and you can get it lined up exactly where you want it to go. Okay, and then just click OK. That's all we need to do right there. Now, if you ever do need to play with the grid settings are right down here at the bottom of the screen, and you can come in here and change the grid. They recommend keeping it set to 0.1 of an inch, because that way when you go to line things up on your schematic, everything lines up on the 0.5 inch and you don't get wonky off kilter lines. Again, making schematics is a little bit of an OCD type of thing. And okay, here we go. 2 over, 1 up, 2 over, 1 up, 2 over, 1 up. And then I'm just going to zoom in again and hit Alt and bring that in and see if I can line it up right there. And then click OK to tell it I am done. And in case you're used to using all the nice drawing tools in Fusion 360's CAD package, where they're just absolutely beautiful, I have yet to find an electronics CAD package where I really like their drawing tools. I don't know why. People know how to make good drawing tools, but I just haven't found it in an electronic CAD package yet. So again, to draw a line from here to here, because those are off of the main grid, hold down your Alt key, click on the end right there, click on the end right there, and tell it OK. There we go. So that's all lined up there. We have a beautiful triangle. Now, if your triangle is less than beautiful and you don't have nice straight lines in here, you can come and highlight one of the corners right there, and you can move that around and drag that around to get the shape of the triangle that you desire. Okay, there we go. Let's bring this pin right up here. That's pin 6. And we're going to bring pin 6 down right onto there. This one is pin 7. We're going to pin 7 down onto there. This one is pin 3. We're going to bring pin 3 up to right there. And right here, we have pin 2, which we'll bring up to right. Yeah, that looks about right. We could set both of them in a little bit, but there we go. We've got some nice spacing for laying that out right there. Okay, now, just to help us when we're taking a look at our schematic and understanding which pin is going to be which, we're going to come along and we're going to add some text right in here. And our text is going to say 1. We're going to bring that over, and we are going to put that right next to pin 1. And if you have to hit the Alt key to move that around and get it to line up nicely with pin 1, there you go. Then we're going to ask it to give us 2 and bring the 2 over here right here. And again, you can hold down the Alt key and get that lined up. Actually, you know what? I'm just going to put that outside right there for now, because it looks like when we do one of the other pins, it'll be nice to put that inside. Let's do pin 3, and pin 3 is going to be right there. Let's do pin 4, and 4 is going to be down. Hit the Alt key, space that right next to there. That was what I was worried about. The 4 was going to overlap with the 2 if I was on the inside. Let's do pin 5. There we go. Just took a minute for my computer to wake up. I think pin 5 will look really nice right there. And pin 6. Hold down the Alt key. Line it up really nicely in here. Oh, that's pretty nicely. And then our final pin will be pin, I guess pin 8 will be our final pin, but our penultimate pin with the Alt key down will be pin 7. And we'll put N 8. There we go, just far enough apart so that there's no confusion that it's on that end. And the final thing we're going to do is we're going to leave space for the name of this project to go. And again, to tell it that this is sort of a macro and automatic numbering thing. So if you have more than one LM386 in your circuit, it's going to number these for us. And we're just going to put that name right in. Not right there because we're probably going to be routing pins out of there. We can probably put it right about there. The name will usually be something like U1 or U2. U somehow ended up being a pretty common term to use for your microchips. And so, okay, we've got our text in here, and it's probably not a bad idea right now to make sure that these all match up, and that if I click on here, that P5 is next to the pin that I've labeled 5, and 8, and 1, and 4. Okay, we were checking them as we went along, but because we're going to be joining things up later on, and we're going to be joining them to their actual footprints for the real chip that we're putting on the board, then I want to make sure that we're both dealing with the same pins in the same places so that when we wire up our schematic, things don't go sideways. Okay, so that's looking like a really nice little LM386 chip. And I'm just going to hit the save button right there. And that is saved right in there. Now, that is the logical symbol for our chip. So it doesn't look anything like the chip in real life. The footprint is what's going to look like the chip in real life. And so we're going to come in here and we're going to call this, you'll call it LM386. I'm just going to say demo at the end because I'm doing a demo right now. And so now I've got a new footprint in here. And this is actually, I could have called it DIP 8 because this is going to be a dual inline package 8-pin socket. Now, Fusion 360 does have a really cool package generator that comes in and actually creates a 3D model of the part and creates footprints for you. But I'm going to encourage you to not use it right now. As of March 2020, Fusion 360's package is still fairly new in the way of electronics, and this doesn't offer you very many options with your copper pads for the footprints. It's pretty good for some of the surface mount components, it seems, but for our through-hole stuff, when you're designing things for the specific needs of a high school or a junior high school class, you're going to want to leave them just a little bit more copper to solder to, and so we're going to make sure that our pads are suitable to help your students have success, because if your students aren't having success, then you're not having a happy day. So let's come in here, and we've got this hooked up right here. So now we have to come in and we have to create not SMD pads. Remember, those are surface mount. You can see it doesn't go through the hole, but we're going to create PTH pads, pad through hole. And you can see the symbol right there shows that the lead is definitely going through the hole. And there we go. And I'm going to create the pad shapes right here in a long pad. So that's the first thing that we're going to do to make it easier for the students. The diameter of the hole, I'm going to set that up to 40. I'm just going to type 40 in right here, 40 thousandths of an inch. And I am going to set the height right up here. Just going to make it a little bit wider than that. It's got auto turned on, but if I can make it a little bit bigger, then if it doesn't etch perfectly or if they're off slightly on their drilling, then life is a little bit easier for us. Okay, this is going to be the center of the chip, so I'm just going to start somewhere over here. Again, we can realign it later on. Pad 1 is always going to be right up here in the top corner. And so I'll just click in here somewhere, and then it's going to be 2 clicks to come down because our grid is 50 thou in here. You'll notice right up here our measurements. So if I'm right there, it says I'm at minus 200, 250. I come down that way. Now I'm at 150, so I've come 100 thou down, which is the standard spacing between pads. 2 clicks right here. And then it's 300 thou across. So 100 thou, 200 thou, 300 thou coming right up in here. And so I'm going to go click, 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 and click. Oops, I'd already had a pad there, so wouldn't let me put it on top. Okay, so that's good. Now I've got all these pins in here, and you can see my numbering works. Pad 1, 2, 3, 4, 5, 6, 7, 8. Just looking at them, as you make the pads bigger, it makes them more resistant to drilling errors and makes it easier for you to have copper left over if there is an etching error. Again, if you make them too close together, though, it becomes too easy for the solder to jump right across there. And it looks like, we're right at the borderline. If we made these just a little bit narrower, we'd probably be okay. That would give us a little bit more space between them. I certainly wouldn't want to make them any bigger and have them getting closer to each other in there. It's going to make it harder to etch the copper out of right there, and it's also going to make it easier for solder to jump between the pads if they make a mistake with their soldering iron. Let's take a look at this first pad right here, because we usually like to do something special for pad 1 to indicate that it is special. That way it means that when the students don't get their chips aligned the right way around, you can troubleshoot it really quickly. So what we're going to do is we're going to change that shape. Instead of making it long, you can choose a different shape in here. Quite often in a lot of packages they have a long package with chamfered corners, which is my favorite one to go with that. But for on here, we might go to a square, and let's change that diameter of the pad up from 70. Let's try, we want something a little bit bigger than that. Let's take it up to 80 and see how that's looking right there. So there we go. We've got something so that the copper indicates that we've got a unique pin right there. So it makes it fairly easy to remember where pin 1 goes. Now the next thing we're going to do is we are going to draw a line around the part to indicate the borders of the part that we're putting over top of here. And that's just to make it show up on the top layer of the chip. So we're just going to come down right here and draw a line all the way around like that, and then just click on OK. And that's okay that overlaps with those pads, because remember, this came in gray because it's on the T place layer, which is the top placement layer, so that when we look at the top of our board, it says, hey, put that chip right there. And the other thing we're going to do on our T place layer is we're going to come in here and we are going to draw a circle, and you'll have to use the Alt key again to get this right in here, but hold down Alt and put your circle right in there, and hold Alt again to get the diameter that you want. And again, a dot or a notch on a chip right here is a reminder of where pin 1 is. You could technically, if you wanted, put this right over top of there, because like I say, they are going to be on different layers. Sometimes it's just a matter of, it's a bit of a pain in the butt for selecting things. Okay, so this is looking pretty good so far. This is our this little X that you see across the, I don't want another circle, thank you, I'm all done with the circles. We can pick everything up, and let's just drag it over so that we're roughly centered on that, because when you bring the part in or when you rotate the part around on your board, that's the pivot point that it's going to move around on. And let's add just a little bit of text right here, and what we want to do is come down here, enter our text, and we want to add the name again in capital letters, so that that will go onto the top layer, and you can see that's on the T-place layer. So there we go. We've got pads, which will, if we do a two-sided board, appear on both sides, but most significantly, they're going to appear on the bottom layer. They're going to be on copper and available for our toner transfer to pick up on. They're about the right size for what we're doing. They're spaced correctly. At this point, sometimes if I'm not 100% sure I've got the spacing absolutely perfect, I'll do a print job right here, and I'll actually print that out on my laser printer, and I'll take the part and I'll hold the part right over top of it to make sure that it's going to fit. And it's always a good idea to test your part before you get too committed to it. As you know, I've already made a part before, so I'm pretty sure this is going to fit. Okay, so that's looking about right there, and let's hit save again right there because we've accomplished something useful. Alrighty, so we now have the symbol and we have the footprint, and the key to making a part is to create the device that links the symbol to the footprint. Okay, so we're going to come in here, and we are going to right click on there, and we're going to say let's create a new device, and again we'll call this an LM386, and this is my demo version. Okay, this window pops up right here, and this is strangely compacted window right in here. We've got to drag that around, and we can play around with some of our spacing a little bit. Actually, it kind of sometimes helps to move that off to the side a little bit so that we can see what's going on. Now, the first thing that we have to do is we have to come in here and we have to add a local package. So come down here to the new button, add local package, and it takes a look in your library and it says, okay, you've created these various packages. Which one do you want to add? And you can click on the one that you want to add. You can take a look at it and say, this is the one that it automatically created with the lovely 3D part in there, which we really don't need. And okay, here we go. So interesting. That was my previous one. Oh, it's just slightly different scale in the view. So, okay, pick your LM386 part. It should look something like that. Click OK. It pops up right in here. Okay, that is good. Now that we've got the footprint over here, we want to add the schematic symbol. So we come up here to Add Part, and we tell it the part that we want to add. So you should see a nice little picture up there, and come in and let's pop that right over top right there. And that's looking really good. Okay, and before we go too much farther, let's just come down here and say that we do want it to automatically keep track of the value, and the prefix that we want it to use for the value is going to be U, because that's a pretty common symbol prefix for a microchip. Maybe that's where the U comes from, the micro. I've always wondered why U for microchip, but that makes sense. So you could have C for capacitor, R for resistor, all sorts of things that you could have going on in there, but we'll say U. Some people might use IC and it would be IC1 or IC2. Okay, so we've got a prefix set up. We've turned it on that it's going to keep track of the values automatically for us. And now what we want to do is we want to go connect. Now in here, we were very, very careful to make sure that we set pin 1 up right in here to be the same as pin 1 on the chip. And where those symbols come from is the data sheet. So if you weren't 100% sure, you could Google LM386 data sheet, and for any electronic part that you get, somewhere out there there's a data sheet that shows you a schematic symbol of it and relates it back to the pin numbers. So we came along and we said, well, over here pin 1 is related to pad 1. So right now we've got pin 1 highlighted and pad 1 highlighted, and we can just go ahead and we can click connect. And so over here we've got a connection from pin 1 right here to pad 1 right up there, so that when you create your schematic this way, you get your actual footprint to reflect that when you switch to PCB view. And pin 2, was to pad 2, and pin 3 was to pad 3, 4, 5, 6, 7, 8. Now, it won't always work out that way, and as you get into more complex chips, you'll have different arrangements, and sometimes you'll have one pin. So, for instance, ground might be hooked up to multiple pads, or you might have some pads that don't have a pin hooked up to them because they just needed that pad to transfer heat into the printed circuit board or something like that. But now we've got that hooked up, and we are okay. And there you go. You can see that our pad numbers have popped up over here, and you can do a quick double check. And 1, 2, 3, 4, 5, 6, 7, 8. Where's 5? Pin 1, pad 5. Oh, earlier on we were changing values, so 5 is probably just not displaying that. If yours is displaying it, that's great. If it's not, I think we're okay in there anyway. But tell you what, we're going to test the part before we get to relying on it in our schematic. So just go ahead and click on Save. And now we've once again saved your library onto the cloud. It's backed up along with the rest of your files. Okay, and you can close that. You've updated your library. You've created an LM386 part. Okay, now we're back over here, and you should be in the schematic view for the Monobox. So you've got your project view, you've got the schematic view, and now what we're going to do is we're going to come up to our library, and we're going to add a part. And the part that we're going to add is from your library. So come in here, look in your library, and click on, I've got LM386 demo showing right in here. And we will go OK. And we'll come in here, and somewhere in the middle of our board at a nice scale, we'll put that in there, and we will say OK. And look at that, it voluntarily went through and put those pad numbers in there for us. We can go back. We do have an option of turning those all off when we design the board, but you can see right here it also named it and numbered it for us. This is U1, the first microchip in the circuit. Okay, so just looking back at our schematics, and so we're going to have to add some resistors to this. So let's use a resistor to test and see if we've got our pins working right. So let's come in here and let's add a part. And we're going to come up here, and our Adafruit library had some nice resistors. And come down here until you find a resistor. And again, if you don't feel like scrolling through and looking at all the parts on here, where did that go? Anyways, you can just go along and you can type in search, and tell it you want to search for resistor. And if you like the American symbols for resistor, there's one right there. And again, the numbers in here indicate the spacing between the resistor leads. And if you want to give yourself a little bit more space, you can go with a 12 millimeter spacing. Let's see, that should be pretty good. You can come down here, and there's a larger resistor there. That would be a slightly more powerful resistor because you can see it's thicker around. So I'm going to go with the 0207/10, but if it looks like that and it's got a resistor symbol, you're probably okay. All right, now that resistor is going to come off of pin 1, and so just looking at the schematic, I probably want to rotate that and put it somewhere in about right here. And I'm going to click OK. And now what I'm going to do is I'm going to draw the net, and before I go too much further, I'm just going to hook that up, say OK right there, and with only one part, I want to check and see, did I get a resistor hooked up to pin 1, and what does my footprint look like, because I want to make sure this is all working, because anytime you work with a new part, you want to make sure that you've got it right. So let's come back to our project right here. And actually, let's save this now that we've got some parts in here. Sorry, come back to your schematic, hit save. Okay, and now when you come back to your project, it's far more satisfying. You've got that diagram showing right there. And let's go ahead and hit new PCB. And and our new PCB file pops up over here. You have to zoom out a little bit because the parts are placed right off the board. You can drag them on so that you can see them a little bit better. And then you can click on R1 and look at that. That is indeed hooked up to pin 1 and our pads are all appearing in the right places. So we're probably off to a good start for making that board. Now I'm just going to click on delete. I don't need that board anymore. That was just a test right there. And I'm going to say don't save. And then it's going to say forward back annotation has been severed, because what that means is that it maintains a continuous link between your schematic and your board. And it's like, somebody just got rid of the board. That's okay. We weren't planning on using that board anyway. You can click on the warning and it will go away. Let's add in some other components that we've got made up and ready to go. So we can add some of our capacitors in. And again, we'll use our library parts for our film capacitors. So for the two non-polarized capacitors, these symbols are the right ones. And you'll see we can come in here and one's going to go in right about here somewhere on the feedback loop to pin 5. And then we've got another one that comes in right over here, and that's going to go down to ground. So we'll say that's okay right there. And let's bring in a few more resistors. And may as well make them all the same. And what have we got on here? I think that was the ones that I used. You can always change the part around if you need to. And so we've got a resistor coming in right over here. And a resistor coming in off of the line, coming into pin 3 somewhere over here. Okay, so we've got some of that coming together. And let's see, we're going to need a polarized capacitor. So you can just search for cap. There's lots of good polarized capacitors in here. And let's go. Again, stay away from the red. The red is a big warning. You don't want the red. That means it's a surface mount component. We want nice green, good through-hole pins. And so we're looking at an aluminum electrolytic. That's for about a 2.2 microfarad. We're looking at a 470 microfarad, not a tantalum. Again, we're back in the surface mount right there. This one only goes up to about 22 microfarad on here, and that's not quite big enough for what we want. So let's take a look in the SparkFun capacitor libraries. And oh, look at that! They actually had a nice capacitor in there. So let's see, footprint, about 5mm spacing, and they say this is 1,000 microfarad radial. I like the bigger pads on that one right there. 5mm spaced hole, 10mm diameter. That's pretty close for our 470 microfarad capacitors, so we can bring that in right there. And that is going to set right in about there somewhere. Okie dokie. Oh, sorry, there is one more of those to come in. Now we don't have to go back and find that again, although it should be sitting here and ready to go. We could just copy that, but we're going to put another one over here, and this is going to come in off of the power supply. Excuse me. And the way they've got it drawn in right here, I guess we can rotate it around and it'll go in like that. Okay, so we've got some parts in right there. And now what we're going to need is we're going to need a speaker and we're going to need a power supply. Now they just use symbols for the 9-volt power supply and the ground. I think we're going to actually use the 9-volt battery clip that we've used in the past, and that is an AB9V part. And so we'll go, okay, let's bring that in. And we will rotate that. I'm using the right click to rotate it around. And I might just put it, oh, didn't mean to I'll put it right there. We can always move it if we have to, and we can always rotate it into a better orientation if we want to. Now, if this window is getting in your way and you want a bigger view, these little arrows right here let you expand your windows. And as we get working on it, you can actually drag these windows out and put them onto your second screen. So if you need more real estate, that's an easy way to take advantage of the additional real estate. Okay, so let's add a speaker in now. And we can come in here and we can just search for speaker. Helps if we spell it correctly. And there should be a couple speakers in your library. And I think we've been using this one here because all we're using is these two pads for it, and we're running the speaker off to the case somewhere else. So these will be external parts, and then we can come in here and let's rotate that around right in here. Put that right up in there somewhere. That's looking pretty good. And what else are we going to need? I guess we need a source of audio. Need more than one speaker right now. And a source of audio to power this whole thing up with is going to come in and sit right in here somewhere. Now, the audio is going to come down, and as I was saying earlier, it's coming out of a pin that we're going to plug into a cell phone or a laptop or something like that. And we've got a couple of different ways of hooking it up, but we're probably going to either mount a socket on the edge of the case that we build for this, or we're just going to directly wire in a plug that we can solder onto the board. So really, we don't need to worry about the exact footprint of what we're going to be hooking up. We just need two pads. I'm going to suggest we actually try 3 pads, because if you want to go stereo later on, having the 3 pads in there is going to have you ready for that, because you're going to have ground, left, and right. So what we'll do is we'll just put a little set of headers in here and come in here and just search for header. And you'll see right here 1 by 3. You can choose from either library and come in here. And there is a really nice footprint for it right there. I'm not 100% happy with the amount of copper that's left behind on there. I think that's going to be difficult for your students to solder. Let's see if we get a little bit more copper right down here. And you can see here in this diagram, oh, they even show us what the header looks like in 3D. You can see here in this diagram that they're using the elongated pads, so you've got a little bit more copper left over there, as well as still being able to have good clearance between the pins. And there's your 3 inputs, and we'll just click OK. So even if we only use 2 of those, that's still okay. Let's bring that around right here, and we're just going to set that about right there. We've got a few more things to add. And now, just to simplify everything as we go along in here, we're also going to add a couple of ground symbols. So let's come in here, and as you recall, ground is not a physical thing, it's a symbol. And it's a symbol that says things that are all hooked together. And that's a nice ground symbol right there. All sorts of different ground signals would actually work right here. Let's just go with this one. Okay, and well, we're going to have a ground symbol for the bottom side of the battery, a ground symbol for down in here, and a ground symbol for the bottom of our capacitor right up over here. Okay, I think we've got all the parts that we need right in there. And so let's come in here and start hooking some of them together. We know that our output is going to come through the capacitor, and it's going to come to the speaker. There is going to be a line that comes off of pin 5 that comes to this resistor right here. This resistor is going to come down to this capacitor right here. That's eventually going to feed into ground. This capacitor is also going to feed off of pin 5, and that is going to form our base boost feedback loop that comes right in there. Pin 4 is going to come down and connect to ground. Let's line our ground up right here. Let's move ground over so it lines up right in there and is kind of on a line right there, and just get it nice and centered in the drawing. And then this one can come in and join right there. Our speaker can come in and join right there. And pin 2 is going to come down. Don't try not to draw right over top of that name right there for U1. If you want, you can come in here and click on the cross for U1. You can actually move that around. You can put it right in the middle of the component if you want. That's allowable right there. And where are we right here? So pin 2 is going to come down, and it's going to come down to ground as well. So click here, and then bring it over right there. Well, we'll worry about the power supply in just a moment here. We're going to have our inputs coming in from our audio jack. So we're going to take input number 1, and let's create a net. That net is going to come out right here, and it's going to come down, and that is also going to come across to ground. And then pin 2, which will be our left channel coming in, is going to come to that resistor right there to provide a bit of a load. Then up to pin 3, we're going to tidy that up in just a minute, but pin 3 is now going to come down to ground right in here. For our power supply, let's see, let's move this right over to here. We'll move this right over to here. We'll move this one right down in here. Let's take this capacitor and rotate it. And, oh. Okay, move it around right over to about there. And then let's add a net from sure we get a connection right there. So what this capacitor is doing right now is it's just buffering the power supply. So because our amplifier is going to draw current in fits and starts when the sound gets loud, the capacitor just helps the battery respond to that very quickly. It's more important when you're coming in off of a wall mount power supply or a charger type power supply, but because batteries do have a lot of surge capacity in them, but that just enables that to work really nicely. Okay, now we need to add some values to things in here. So I think we've been through that exercise before. Just come along here and value. So this one right here is going to be 100 ohms. We'll mark that out as 100 R. Okay, and we want to rotate that so that it's nice and easy to read. We want to rotate R3 so it's nice and easy to read. Zoom in a little bit if you have to. Okay, and then let's move these around and make sure that we've got some nice spacing for them right in there. For our capacitor up here, let's space it down a little bit. Let's just drag that point up. I guess it wants to be that way. That's how I drew it. Oh, let's get that. Why is that line no longer straight? Get your lines nice and straight and square. Pay attention to the OCD right on there. Okay, C4 capacitor. Let's rotate that so that it's vertical. And C4 right in there. Our value on C4 is 100 microfarads. So take the capacitor. We're done rotating. Thank you. Hit escape and come in here and on the. I don't know why it really wants to rotate on here. So come in here and we want to change the value. Why will you not let me change your value? That capacitor just wants to keep on moving. Let's carry on, and we'll come back to that capacitor in just a moment because it's got the wrong value posted in there. Now remember I said that line's not nice and straight. Let's move that up just a little bit. Let's move that up a little bit. Let's take that DGND earth. Actually, we don't even need it to say that. So if we click on that, let's just delete that. That's unnecessary. We know that is ground right in here. And let's take this pin right here. Oh, I'm deleting those. Let's just draw that back in, nice and straight. Okay, so that comes across right there. And now this one's wonky a little bit down here. Let's move that up and square it up. I knew it would straighten out eventually if we kept doing that. Here's a resistor that needs some values. There we go, right click on the resistor. New value for that is 10K right in there according to the schematic. Okay, and let's rotate that into position. Let's rotate that into position. Let's drag that up right there. Drag that up right there. C1 should be down here closer to the capacitor, maybe right underneath. And let's go value for that capacitor is going to be 0.033 microfarads. Okay, so you can do your metric conversions and you can say that's 033U, or you can also express that as a 33 nanofarad or 33N capacitor right in there. Your metric conversions are very important to know. Okay, it's not letting me pick that up. Why is it not letting me pick that up? Sometimes if, oh, because I had to hit escape. There we go. I just had to hit escape. 33N. So we're getting all of our values in here, on here. Value, and this is going to be a 10 ohm resistor. So we can just put 10R right here. And again, let's take this and rotate that into position, because getting your schematic to look good is a very important part of getting people to be able to read your schematic properly. Properties, oh, sorry, I didn't want properties for that capacitor, I wanted value. And the new value for C2 in there is 0.047 microfarads. So again, you can do your metric conversion and call it a 47N or 47 nanofarad capacitor right in there. And let's rotate that into position, and then drag them up so that we can see what they are. Now, if you've got a very compact schematic and you can't fit everything into there, then what you could do is you could just have C2 right next to that, and then you could have a listing offboard of what all of your parts were. We don't need that to say DGND earth. Hit escape on there, and we should be able to come in there and delete it. There we go. And same thing for our speaker. Right in here, its little crosshair is right in there. We're in delete mode. Let's get rid of that DGND earth. We don't need it to say that either. Okay, remember to go through and finish up all the rest of your alignments on here. And note that pins 7 and 8 are left detached. So when you've got everything all tidied up, add a little bit of text with your name on it. So that is under the where are we? The draw commands in here. It's like document draw text, and so this will be Monobox LM386 amp. And it is April of 2020. We're doing this, and bring that in here and put that in so that somebody knows what you're doing. Okay, and it didn't add a name for our U1. So that's why we mentioned that it uses the LM386 chip, but we should probably add a little bit of text right in there saying that that is the LM386. That fits in there really nicely. Okay, and of course we still have to come up and adjust the values on the capacitors right here. For JP1, we might want to add a little comment that this is your audio in. Probably line that up a little bit nicer. And again, if you have to get really fussy about lining things up, you can hold down that Alt key to get a fine movements on your grid. Okay, I'm going to save that. And again, like I say, I haven't finished tidying this all up. There's lots of stuff to be done in here, but we've got a pretty neat readable schematic. Other than that, we could go back to our part and we could turn some of these pad numbers off if we wanted to. But let's go ahead and we come back to our project window right here. And you can see there's our schematic in that window. And now when we create a new PCB, it all pops up in here. Our parts all come in right here. And I just want to make sure all those parts are looking okay. And that what we want to do is we do want to check and make sure that the right parts are going to the right places. So let's just see right on here. Our speaker is connected on one side to pin 4. Well, that makes sense because pin 4 is connected to ground. And on the other side, it's connected to a capacitor. And that capacitor is connected to, let's rotate that into place right there. And that capacitor is connected to pin 5 right there. So go through and check all the rest of your parts to make sure that they're all connected into the right pins. I can see our power supply comes in here to pin to the positive side of a power capacitor. It comes down here and hooks into pin 6, which should be good. So it looks like we may be well on our way to making this happen. Alrighty then, have fun routing, and if you need some inspiration, download the Flow-Free app for your phone or tablet and see how you do. Have fun with the routing challenge. Remember, before you start doing too much on here, to come in and set your design rules. Okay, that's very important that you don't forget to set your design rules. And remember to do your routing on the bottom layer. You don't want that red layer. If you see red, that's a warning. You don't want that. Your design rules, okay, you come in here and this is where you make sure that you've only got that bottom layer turned on. So you put 16 in right there. Oops, I didn't mean to finish doing that already. So layers are 16. We've got copper down here. We make sure that we give clearance between our wires and our pads. It's nice if we can give them 20 thousandths of an inch of clearance. We're not using vias, so it's not a big deal. We want to, there we go, 40 should be fine right there for clearance distances. Size, our minimum width of a line that we're tracing on here. I've seen some people forgetting to update that, and it's really important to give yourself at least 20, ideally 25 or more thousandths of an inch for your traces, because otherwise they're just really hard to etch. Your annular rings, okay, we're not worried about the top and the inner layers, but on the bottom layer, it would be nice if they had a minimum of 20 and a maximum of, we could go up to 50, and let's just make it a little bit larger. Apply that. That makes some of the pads just a little bit bigger. Okay, and that's the main thing that we need to worry about right on here is bumping up some of those pad sizes. Looks like some of these bumped up almost a little too big. So let's go back and just change. That was our annular rings right here. Let's set that back to 25% of the drill hole size on the bottom layer, and let's set that max down to 40. Okay, minimum. Let's set that back to 15. Apply, there we go. And you saw 15, 25, and 40 got us some reasonable sizes on those pads. We already had fairly big pads on those. Okay, but now you can just do a quick check. You've got your bottom layer on. When you come to route something, click on what it is that you want to route. No, sorry, come back to design, tell it you want to route manually, and there you go. It's coming out in blue, and it's coming out at a reasonable thickness. Okay, I don't actually want that one routed, but I'm going to cancel that and undo that. But that should be about the thickness of lines that you're getting on there. Go ahead and get it all routed. I'll provide my solution to it in another video in a little while.